How can we determine the density of irregular objects? Irregular object is an object that has got no specific dimension. This is an example of irregular object. This is the irregular object. To determine the mass of irregular object is very simple because you just use beam balance. A beam balance is definitely used to obtain its mass. So its mass is definitely obtained by using a beam balance. Kwa uzito wake ni rahisi kuupata kwa sababu unachukua tu mzani, unapima, unapata mass of irregular object. Lakini shida, the problem comes that you have to determine its volume. You have no specific formula that can be used to determine the volume of this one. Kwa hakuna kanuni ya kutafuta volume ya hii hapa. Kwa unachokifanya sasa, unatumia measuring cylinder, ambapo a graduated measuring cylinder, ambapo sasa unachukua. Kwa hiyo unajaza maji kwa wakati wa kwanza, unajaza maji bila kutumbukiza kile kitu. Halafu unamesha ile volume ambayo umeipata, ambayo tunaita volume 1, ambayo ni initial volume, ambayo ni V1. Baada ya kuwa umejaza maji, hapa unatumbukiza kile kitu ambacho unataka kukipima, ambacho sasa imagine hapa sasa umepewa hii hapa, ndo hiyo cylinder, hiyo cylinder ambao sasa baada ya kuwa umetumbukiza, unatumbukiza jiwe lako humu, alafu kwa umelifunga kamba. Kwa maji yale automatic, ukitumbukiza jiwe yale maji yatapanda. Yakipanda yale maji, ile volume ambayo imeongezeka tunaita final volume, ambayo ni V2, ambayo inakuwa ni final volume. Kwa final volume inapatikana wakati ukiwa umetumbukiza jiwe. Kwa mwanzoni unachukua tu, hata kama ni jagi ambayo linakuwa graduated, maana yake inakuwa na vipimo. Kwa linakuwa lina vipimo, unapima. Ukishapima sasa tayari unapima ile volume ya maji ambayo kabla hujatumbukiza lile jiwe. This initial volume is the volume of the liquid before dropping an object into it. But the final volume is the volume of liquid after you have dropped an object into it. The liquid will rise. The level of the liquid will definitely rise. Before it was definite, it was here. Now, this is an increase of the volume of the liquid. And therefore, to find out the volume of this object, you take the volume of the solid will be equal now to volume, the final volume minus initial volume. Kwa maneno, kwa sababu hiki kilichoongezeka ni ujazo wa liquid ambao sasa imekuwa displaced by the solid ambayo imekuwa immersed into it. And therefore from then you can determine what we call it, whether it is centimeter cubic, that is the volume of the solid. Now the volume of the solid is equal to the volume of the displaced water. This is the amount of water that have been displaced, and that is why we call it the volume of the solid. And therefore, first of all, you have to determine the volume of the solid, and the mass is only definitely measured by using beam balance. It is from then now you can determine the density, because we know density is equal now to mass over volume. But remember, mass is determines, and also the volume of the solid is determines, that is V2, now V1. And therefore we say density of an irregular object is equal now to mass over volume 2 minus volume 1. But I've said this volume 2 is final volume, and it is the volume that is obtained after you have dropped an object into the liquid. And the first volume, that is volume 1, that is initial volume, and it is obtained before dropping an object into it. So the only difficult thing here is to determine the volume of an irregular object, because irregular objects have got no specific dimensions. So it is so difficult for it to determine it. Once you have determined its volume, it is where now you find out what is missing, which is now density. Now density, in short, density of an irregular object is determined by taking mass over final volume minus the initial volume, and this is given as gram per centimeter cubic if it is given in gram, or kg per meter cubic. But actually always or usually we use gram per centimeter cube, because hivi ndivyo ambao tunaweza tukadetermine density of an irregular object.